ICPAC, which deals with climate prediction, based in Nairobi, and C1, which deals with conflict and early warning, based in Addis Ababa, as well as the development partners whom gave us some financial support, that is the German government through GIZ, European Union, and UNDP. And why is this so? Because every piece of information really mattered at this point. On to the second phase, which is the participatory mapping session. Now, as the name suggests, this whole process was really participatory in the sense that from other stakeholders whom we had identified in the scoping mission, we all brought them together through series of mapping sessions. Now, most of us who are listening to me right now in this forum right now, we all fall within this category of knowledge pillar, whereby we have codified knowledge. It's easy for us to transfer the knowledge which we have. But again, we are just at the tip of the iceberg, of the knowledge iceberg, if I may call it, because there's a whole wealth of information which we do not usually know, or which is usually not documented, as in the case of transhumance. These have been routes which have been in existence since time immemorial, but no attempt was made earlier on to document them, or rather to understand how the seasonality affects the pastoral community's mobility. Hence, out of those participatory mapping sessions, 220 stakeholders were engaged, whereby they were able to translate the information they had in their mind, or rather through the undocumented knowledge they had on transhumance, as well as the watering areas, the seasonal grazing areas. You're looking also at the conflict hotspot areas, resource and conflict management plans. So these are the people whom we involved, and as you can see for the pastoral groupings, we managed to get hold of the major pastoral groupings within the cross-border areas. Now, these are some of the sessions which we had with the communities. We indeed went on the ground to interact with them, to get as much information as we could throughout the whole session. Of course, gender really played a key role in the whole thing, so to come able to get the whole dynamics of the whole transhumance. At the end of the day, these were the kind of the outputs you are getting from the participatory mapping sessions. Very clear mind maps, rather, of how they interpret the seasonal movements, as well as the conflict areas, conflict-prone areas, and the seasonal grazing areas. And as a matter of validating these outputs at community level, we also encouraged the community elders, the pastoral community elders, to also append their signatures by their products which they had produced. This is an example of the case of Kenya-Ethiopia border, where we had the Gabra, the Boran, the Gare, and the Rendile elders append their signatures next to, of course, the product which they had produced. Now, these participatory mapping sessions, there were 4 in number, 5 actually, 2 in Kenya, 1 in Lodwar, another in West Pokot, another one in Karamoja region in Moroto, then Moyale in Ethiopia, and 1 in Marsabit town for Marsabit County, or rather the Kenya side of the border. The third process, or the third stage, was the spatial analysis, and this is where the GIS and remote sensing technologies come into play. And in this case, it served as a bridge to merge the good practices, the tacit knowledge which we had during the participatory mapping sessions, and now with the technology. Will there be any overlap? And in this now, we are looking at the multitemporal analysis. We are looking at the delineation of the transhumance routes and resources, which we got from the previous sessions. And again, we are looking at the rangeland profiling and characterization. On the screen is the output which we had along Kenya-Uganda border. 14 cross-border routes identified. with very clear exit and entry points, as shown there, as well as dry season grazing fields. The same case applies to Kenya-Ethiopia border, where we had 20 routes, transhumance routes identified by the community. Grazing areas are usually fluid in nature. By this I mean is that they heavily depend on rainfall. So the more variable the rainfall is, the more variable the seasonality will be within the grazing areas. So in this case, we ran a series of correlation analysis just to understand when is it, or during which periods we have the peak of this biomass, and where do we expect deep seasons. And so we had rainfall data from charts at 5 kilometers, analyzed over time, over the years, as well as biomass, now using the proper V at 1 kilometer and aggregated at kilograms per hectare, for us to have a feel of how the biomass is faring over the whole season, in a typical season or a typical year. And as you can see, it correlates very well during the wet season experience within the region. This is March, April, May, and of course, October, November, December. And this also correlated very well with the seasonal calendar, which the pastoral communities had given us earlier on, shown below, during the participatory mapping sessions. Now, this is the case of March to May, the wet season. And as you can see, as the season progresses over time, that's the dry season, which is June to September. You can see that there is a shift in the biomass content, with it moving towards the sides of Uganda, South Sudan, and Ethiopia. So with this, what it means, we anticipate that it's going to be movement of pastoralists, of course, to where there is surplus of that biomass, which is pasture in this case. And of course, as the rains come in October, December, there's that replenishment of the areas which were once scarce, and then the pastoralists are able to move back. Now, allow me to take you back to the year 2016 so that you can be able to understand why it's very important for us to really monitor the range, or rather the biomass. So this is the wet season, that is March to May 2016. That is the dry season. Again, the same principles apply. Then come October, December. The rain should have been good, but it didn't really rain very well. So there wasn't much of replenishment of the dry season biomass from the previous season. So what do we see is that come January, February, we have a very dire situation at play. So you don't have enough biomass to sustain the livestock during this short dry season period before it rains again in March, April, May. So again, this is very important because you'd want to get information for purposes of early warning for early action. Again, just for us to appreciate the seasonality in the pasture, this is the case of Kenya-Ethiopia border. Again, just showing how much there's such seasonal variability when it comes to biomass. Now, we're not just only dealing with mapping the seasonality of the pasture, or rather the biomass, but you're also looking at the rangeland characterization. In this case, what do I mean? Based on the land use land cover over the cross-border areas, we wanted to have a feel of how much of this biomass is aggregated according to the different land cover types. And why is it important? It's because the different livestock types feed on different land cover types. So we have browsers, such as goats and camel, which of course feed on shrubs and some bit of woodland. And again, we have grazers, as the name suggests, which feed on grass. So that is cattle and sheep. So we want to understand which areas are within the grasslands, how is the biomass performing over the whole season, so that we can be able to anticipate where would we expect an influx of these grazers vis-a-vis the browsers. So that we came up with temporal seasonal profiles of the biomass as well within these specific land cover types. Water and grazing come in hand. And as you can see, and I'm sure you've often seen, that most of the time where the pastoralists usually graze, they also want to graze near water sources. Because just like us human beings, we can stay for long without eating, but water, we need to take some water. So the same applies also to the livestock. So in this case, you see that we came up with a water accessibility index based on slope and distance from the water points. And with that, we were able to have a feel which will be the first areas or access areas when it comes to accessibility by the pastoralists during the dry season. So as you can see, this is the point, the first line of access for the pastoralists. Then again, as the drought or the season progresses, they move much more further to the other grazing areas. And these are the same areas which also overlapped with the dry season grazing fields which you had gotten during the participatory mapping sessions. Quantity of biomass is not good enough. You also want to look at the quality. Now, these are some of the common invasive species which have infested the cross-border rangelands. So we have the blackthorn, the whistling thorn, the false umbrella thorn, and the Prosopis julifera, commonly known as madenge. Now, in this case now, with another different initiative, we embarked on mapping of these invasive species based on the using Sentinel-2 data and based on the survey index, that is the soil adjusted vegetation index, for us to have as a proxy indicator, for us to have a feel of how the distribution of this invasive species within the cross-border rangeland. And of course, with this, now we can be able to mask out these areas which are infested from the whole area so that we can have a good feel of what is happening on the ground in terms of biomass concentration. That initiative was supported by the World Bank. The last phase is now the harmonization and validation, and this basically involved cross-border meetings. Now, remember the participatory meetings which we had, you were doing them in country. So now this we had to have 2 cross-border meetings so that we can now bring all these people together. And this now involved gallery walks. And for them, where they were critiquing rather the information which we had presented to them, so it can be a true representation of what is on the ground. So now, why would we want to map these transhumance routes and grazing resources? Other than just the mere fact that we'd want to regulate mobility, we also want to link it to corridor development. And why is it so? Because we also want to appreciate the laws of supply and demand. Now, the map on your right basically shows, for instance, the daily water requirement that is needed by livestock daily in cubic meters. So now, with what we have, with what nature gives us, is it able to sustain that kind of population? And for how long? Are there areas where we'll need to come in and support these pastoral communities, maybe through further production or through drilling of more or establishment of more water reservoirs, especially along these transhumance corridors? A case in point, for instance, if you're looking at groundwater, which areas will be best for us to drill more boreholes for these pastoral communities, and as well for use for human consumption? So the supply-demand law really comes into play. And again, this also helps us to have targeted investments, to know which areas would be appropriate to have certain kind of investments, and again, provide early warning information for early action, and for coordinated programming. Now, to support this, these cross-border areas are very vast in area, and some of these areas also are, in terms of infrastructure, they're not very well developed, and also for purposes of security as well. So we came up with this innovative mobile platform with the S3 products, whereby we do remote field collection. So in this case, with this system of the dispatcher, which is myself, and working together with the field monitors, who are mostly the project teams in the cross-border areas, we're able to collect information on rangeland, water, livelihood, animal health, and education. Because again, these livestock are not moving alone. They're moving with people who also need health and education support also. So with this, we're using survey 1, 2, 3 and collector, more or less, to collect field data and relay it to our online dashboard, where you're able now to monitor and visualize in near real time. And an example of the output of such is what we were able to do for the cluster 1. This is whereby we managed to collect over 3,000 resilience enhancing investments, which have been channeled within this cluster. This is an ongoing initiative, of course, and which will also cover the other clusters. And as you can see, that the portal is actually public to everyone, and it is a contribution to everyone who provided us with information. So this was in support with the FAO regional office, and again also with World Bank, to come up with the field data collection that came up with such kind of a platform. So thank you once again for listening through this presentation, and please reach us out through our social media platforms as well. We have data access portals, which is open to the public. We have GeoNode, which you can easily be able to download information, started information, and keep on track on what we are using. Also from the other specialized centers. Of course, our website is also very much detailed with information as well. And just as I log off, there is also the COVID tracker, which we also have. Be sure to also visit what we are collecting in terms of COVID. And of course, the issue of the desert locust, which I had Gerald mentioning, we also are tracking this movement of the desert locust. So this is being done by our sister organization, ICPAC. Please be sure to go and visit this site. Thank you once again, and happy GIS Day.